Guys, so welcome to the math subject solving section. So we're now solving the 64. What is the flux of the vector field? So basically you have some vector field F, and then there is a surface, and you see this surface basically a hemisphere. And he asked about you this flux. So basically you need to calculate FDS, and then this is S. So you basically you can change the polar coordinate, the brute force calculator, the integral. Maybe we can do this. Okay. So this x, y, and z dot with the n. So the normal vector is basically the x, y, and z. Notice that since this is hemisphere, so we have dA. So we have x squared plus y squared plus z squared, which is 1 dA. So the answer is the surface area of this part. So 4 pi times half, 2 pi. The answer is E. Basically we are done. But so when I first time solve this question, I do not use this way. I use divergence theorem to solve this. Okay, so let me show you how to use. So this is your area, right? So basically the second way is that this is S1, this is S, and I add another. I close the surface, define S2. So basically, from divergence theorem, that we know this is closed surface, and this will equal to the divergence. And the divergence for this F is partial derivative of x with the first component, and the partial derivative of y with the second component, and the partial derivative of z of the third component. So we have x, y, and z. So it's 3 times the volume, and the volume is 3 times a half the volume of the sphere. Of unit sphere is 4 pi over 3, so it's 2 pi. But what we need to compute is this one, does not contain S2. So now we need to compute S2. And for this S2, the equation is z equals to 0, and the normal vector is minus z hat. But you can see this when f dot with minus z hat, the only remaining component is z. But this equation, this plane that has equation z equals to 0, so this is 0. So this turns 0. So all we get is 2 pi. So you can use the divergence theorem, or either just brute force compute this, and you can get your correct answer. The answer is E.